Focus of this class is on non-renewable source of energy, and inside non-renewable source of energy I want to talk about nuclear fuel or nuclear energy. What is nuclear fuel? Uranium-235 is used as nuclear fuel all over the world. And nuclear energy, the energy obtained from the nuclear reaction, energy obtained by the nuclear reaction is called nuclear energy. Now, new word came, nuclear reaction. What is it? How it is different than chemical reaction? It is very different than the chemical reaction which we did in chemistry chapter. In chemical reaction, I want to mention them. Chemical reaction and nuclear reaction. Chemical reaction, nuclear reaction. There are some basic difference between them. They are quite different. In chemical reaction, actually, electron takes part. Electron takes part in the chemical reaction. I want to mention just the point only. Now, in nuclear reaction, nucleus of the element takes part. Electron takes part in the chemical reaction. You know about this. In any chemical reaction, there is either the transfer of electron occurs from one element to another element, or sharing of electron occurs and new compound forms. In this way, in chemical reaction, electrons are involved in the chemical reaction. But in case of nuclear reaction, it is very different. Nucleus of the atom takes part in the nuclear reaction. It means after the nuclear reaction, the number of neutron and number of proton contained in the nucleus alters. It means if number of proton and neutron becomes different, then completely new element forms. This way, nuclear reaction, nucleus takes part in the nuclear reaction, but in the chemical reaction, electron takes part in the chemical reaction. There are some other differences also. Just for example, number 2. The mass of the reactant is always equal to mass of the product in case of chemical reaction. We can say a little nicely, sum of the mass of reactant means which takes part in the chemical reaction, is equal to the sum of the mass of the product. Product means which forms after the chemical reaction. In case of what? Chemical reaction. We are talking about mass here. But in case of nuclear reaction, the sum of the mass of reactant is always greater than the sum of the mass of product. What it means? It means the mass of the reactant is more, mass of the product is less. It means there is destruction of mass. We can talk about this destruction of mass. There is no any destruction of mass. Sum of the mass of the reactant is equal to sum of the mass of product. In this case, the sum of the mass of reactant is always greater than sum of the mass of the product. Now we can see other difference also. Look at this third one. In chemical reaction, either a certain amount of energy is used for the chemical reaction, or by the chemical reaction certain amount of energy produces. Either the energy is used for the chemical reaction or energy produces from the chemical reaction. But in case of nuclear reaction, tremendous amount of energy always produces. There is no any required amount of energy for the reaction to occur. In nuclear reaction, tremendous amount of energy always produces. We can talk about the energy. In this case, I am also writing energy because I want to save time. In this case, what I told you, either the energy is required for the reaction or energy produces after the reaction. In this case, what I told you, tremendous amount of energy always produces. Now, these are the basic differences between nuclear reaction and chemical reaction. We can go through other differences also, but in this level, we don't have to go to detail. Now, nuclear reaction is quite different than what? Chemical reaction. Now, let's talk about types of nuclear reaction. we are taught about type of chemical reaction in chemistry. Likewise, nuclear reaction is basically of two types. One is called nuclear fission, another is called nuclear fusion. There are two basic type of nuclear reaction. One is called nuclear fission, and another is called nuclear what? Fusion. Now, what are they? What is nuclear fission reaction? A nuclear reaction in which a heavy nuclei splits up into comparatively light nuclei with the release of tremendous amount of energy is called nuclear fission. Just for example, we can give example also. In nuclear power plant, uranium nucleus is bombarded with neutron and it splits up into barium and krypton. Barium and krypton is its nucleus is lighter than uranium, and that's why comparatively light nuclei produces with the release of tremendous amount of energy. That's why we can say this is a reaction in which heavy nuclei splits up into comparatively light nuclei with the release of tremendous amount of energy. But in this reaction, the light nuclei fuses with each other to form comparatively heavy nuclei. How can we give example? Example is in the stars and in the sun. What is happening in the sun? The hydrogen nuclei, which is comparatively lighter than helium, hydrogen nuclei is constantly fusing with each other to form helium nuclei, and which is comparatively heavier than hydrogen nuclei. In this process, a part of the mass is destroyed, and that destroyed mass converts to tremendous amount of energy, which we are getting in the form of solar energy. In this case also, certain mass of uranium destroys, and destroyed mass converts to tremendous amount of energy. In both the cases, energy produces. Now, let's talk a little more about them, a little difference about them. One, we can say definition. Yeah, just now I told you about definition. And second point, what can we say? Comparatively, energy produced by fission is less than energy produced by fusion. Less energy. More energy. Actually, both of them produces tremendous amount of energy, but in every fusion reaction, the energy produced is more in comparison with the fission reaction. That's why comparatively energy produced in this reaction is more, in this reaction it is less. And nuclear fission, no need of energy. I mean to say, this reaction occurs when uranium nucleus is bombarded with neutron. It occurs when a neutron enters into uranium nucleus, the nucleus becomes unstable and it breaks down. And no need of high temperature and pressure, no need of high temperature and high pressure in this reaction. But nuclear fusion reaction requires very high temperature and tremendous pressure to occur. This requires what? Very high temperature and high pressure is needed for the nuclear fusion to occur. These are the basic differences between nuclear fission and nuclear fusion. And I told you about renewable sources of energy first in previous class about the fossil fuel. Today's class I told you about nuclear fuel.